Welcome to the Industrial IoT Spotlight, your number one spot for insight from industrial IoT thought leaders who are transforming businesses today. With your host, Eric Walenza.
Welcome back to the Industrial IoT Spotlight podcast. I'm your host, Eric Walenza, CEO of IoT ONE, and our guest today is Alistair Fulton, Vice President and General Manager of the Wireless and Sensing Products Group at Semtech. Semtech is the creator of LoRa technology, which has revolutionized IoT by enabling data communication over a long range using very little power. In this talk, we discussed trade-offs between alternative wireless connectivity solutions, and we also explored how LoRa is being used in applications to combat the spread of COVID-19. If you find these conversations valuable, please leave us a comment and a 5-star review. And if you'd like to share your company's story or recommend a speaker, please email us at team@iotone.com. Thank you.
Alistair, thank you so much for joining us today.
You're most welcome, Eric. It's nice to talk to you.
So, Alistair, before we get into the topic of Semtech and LoRa, would love to learn a bit more about yourself. I see you have something like 25 years of experience in Internet of Things businesses. Where did you first touch this topic?
That's a good question, actually. Yes, you make me feel very old with 25 years, but yes, it does add up to about that. I started first in IoT, actually before it was called IoT, back when it was called telematics and machine-to-machine. And like many people in this space, I started originally in the cellular space, way back in the 2000s with Telefonica O2, first of all O2, looking at a variety of different business models. And at that stage, telematics was seen and M2M was seen as a relatively niche segment. We actually used an old paging network to support a telematics business. But from there, and back in those days, everyone was talking about connected vending machines. I think people still are talking about connected vending machines to a degree. The nature of IoT, the way it's thought about, and really the role that IoT plays in industry has obviously grown exponentially since then. After leaving O2, I actually ended up building a bit of a consulting practice with Deloitte Consulting, looking at connected device technologies. And I should say, even before O2, my earliest start was in product development, and we worked on a connected vending machine back then. But the practice I kind of worked in Deloitte was really hands-on, working with customers, helping them build first business cases, but then actually implement IoT solutions, which is what led me into Microsoft. I joined Microsoft, I think, in 2009 within a product incubation unit. And the first thing that I focused on was IoT, building a concept and then a platform that over many iterations and the involvement of many folks with bigger brains than me into Azure IoT. Then following Microsoft, I went to Hitachi and helped build the Hitachi Lumada platform, which, unlike Azure IoT, I think is one of the stronger platforms in the market today. I'm not just saying that because I have involvement, but from a developer perspective, the range of tools is very rich. There are many others. AWS has an extraordinarily strong platform as well, and there's a long tail of folks with maybe more specialty. What we focused on with the Lumada platform was industrial IoT, and really building a vehicle to encapsulate Hitachi's a century of OT knowledge, of industrial process knowledge, into software tools that customers could use to optimize their own processes, whether those processes were heavy manufacturing, like hot rolling steel mills, transport, mining, and so on. And then I moved into Semtech, which was seen by many of my colleagues as quite a strange move, moving from the world of software and cloud, which is certainly growing by the day, into the old world of silicon. I made that move for a very specific reason. In all of my years in IoT, either building solutions or building platforms, like many others, I constantly came up against the same question, which is, the tools are great, the platform's great. How do I connect everything? And I don't mean 5% of my assets. I mean everything. I mean all of the assets. And particularly in industrial IoT, having that expanse of data visibility into a process is really key if you're going to drive the sort of fairly small cost optimization opportunities that the IoT creates, sampling isn't enough. And the fact of the matter was that there aren't really very many good technical solutions to that. And I've kind of had cables pulled through factories, cellular modules, Wi-Fi modules. The pain in each of those solutions that are strong in themselves when it comes to integration and interoperability is quite extreme. And I came to Semtech because Semtech is responsible for LoRa, and LoRa is the underlying silicon layer behind the growing LoRa WAN protocol. And no tool does every job, but LoRa WAN solves for, I think, a largely unmet set of needs around low power and super low power, long range, mobile connectivity. And I think particularly relevant in the industrial and the enterprise space, a network technology that enterprise customers can deploy themselves. It's an unlicensed spectrum. I can buy a gateway. I'm a network operator. And that flexibility of deployment really lends itself to a lot of the problems that IoT solution providers face in helping their customers realize the value of IoT. Because as I said, the platform can have all the bells and whistles, but if you can't ingest data into the platform in a low-cost way, your customer never gets to see those strengths. So I moved into Semtech. The one thing that struck me about LoRa coming in, again coming from my background, was the technology of LoRa WAN fits a specific need. It's too hard to use, and by that I mean the level of embedded development skills that you need in working at the edge in IoT is often really significant, or you're trading off cost. So you can go down the cellular module path, and that's a perfect solution in many cases, and that abstracts you away from the underlying hardware. So you, as an application developer, you can just focus on the application. Why can't we do that with LoRa WAN? Was really my first thought in coming into Semtech, and that's exactly what we've been doing. We've been applying the tried and tested techniques of firmware-based abstraction, commonly known as modem-type products, and we've built a range of different cloud services which are intended to take really quite complex areas of development, like calculating the location of an asset, and turn those into API calls. Because at the end of the day, developers don't really want to spend their time calculating location. They want to spend their time using that data to build an application that does something interesting. And so that's the approach that we've been taking at Semtech, to really focus on simplifying the technology and enabling the broad range of IoT developers, many of whom come from a cloud background, from a mobile application development background, enabling them to take advantage of the technology.
Interesting. So coming somewhat full circle back to connectivity, but with a completely different...
In some ways, yes, actually, yeah, that's true.
The bulk of our conversation is going to be focused on LoRa WAN, but maybe you can give us a quick overview of Semtech, because Semtech certainly has a broader scope. And then I'm actually interested in understanding the role of LoRa within Semtech, more of the relationship. So how the IP is owned and how it's what the ecosystem looks like. Because of course, even Semtech to some extent owns LoRa, but there's a very strong ecosystem that's actually bringing this LoRa to the market.
I think Semtech, apart from Hitachi, is one of the oldest companies I've worked for. It's been around for about 60 years. Semtech has always focused on solving complex hardware-related challenges. So it's a silicon company by background, still largely a silicon company today, and will be a silicon company tomorrow as well. But we've got three real business units, one of which I'm responsible for. I'll talk about that in a moment. But the other two business units are our signal integrity product group, and they're really focused on high bandwidth video signal processing, data processing, building data tools for 5G base stations and data centers. And so really, actually, when it comes to things like small embedded devices, like really right at the other end of the scale, we have a business that is a protection business, which is, in terms of pure physical scale, kind of closer to me, I guess, in that most of the consumer electronics that you use have protection in them against electrostatic damage. So either from your own body static or from environmental static. And that's what the protection group focuses on, building extremely small components that deal with those power surges in an extraordinarily efficient way. And then there's the wireless and sensing business unit, which I'm responsible for. As the name suggests, there is a wireless component, which is largely LoRa, We also have a range of FSK products that we've had for a number of years, and sensing. And the sensing business is focused on specific absorption protection. So mobile phones increasingly these days have a chip on board that senses proximity to your body, calculates how much radiation is being absorbed by your body, and moderates the output of the device accordingly to keep you within safe ranges. And that's a product that we've had in market for a number of years. I think, arguably we're market leader in terms of the technology, and we're in most of the phone brands with which you're familiar, and most of the tablet brands with which you're familiar as well. We also have a wearables product range within that business as well, which uses a very similar set of techniques for a different outcome. So if there is a touch-based interface, for example, those are scenarios that we support. Now, the wireless business, as I said, is LoRa, and you asked about the role specifically of LoRa within Semtech. LoRa, I think, is just beginning to enter growth phase. And so from Semtech's perspective, it's really, really a very big focus of our business, driving adoption and making sure that we're supporting, as you said, the growing ecosystem. We realized, I think, and this is before my time with the company, I think the first realization upon coming across the startup that built or invented LoRa was, wow, this is a great technology, and this does a bunch of things that particularly on the low power and range vector, other technologies don't do. But also, like every great technology, you need an ecosystem around it. There are many technologies, not just connectivity technologies, that were great in and of themselves, but they didn't grow a network of friends, if you like. They didn't grow an ecosystem. And so right at the beginning, Semtech focused on, okay, what do we need to do to kickstart an ecosystem? The way I'll describe the kind of topology of LoRa. So there is LoRa. LoRa is the name for the physical layer, the chip. There is LoRaWAN, which is the protocol and the modulation that sits on top of LoRa. LoRaWAN is defined and managed by an organization called the LoRa Alliance. And that separation was one that Semtech made very early on, recognizing that a small silicon company isn't going to be able to understand the needs of the broad market. And indeed, the protocol should be driven by the needs of that market rather than any one member of that ecosystem. We do have ownership over the IP behind LoRa, and that's something that we've maintained, probably not for the reason you think. It's actually because one of the distinguishing characteristics of LoRa is also that wherever you go, whichever device you pick up, fundamentally the radio layer is the same. And that homogeneity creates a much higher level of interoperability straight out the box. It contrasts with some other technologies, which again, I'm a firm believer in interoperability and the need to provide developers with a toolkit that ranges from Wi-Fi, Bluetooth, Zigbee, all the way through to cellular. But many of those technologies suffer from the fact that they're fundamentally different when you come down to the hardware layer. And that drives the level of complexity into the development process and to the ecosystem, which takes, it takes work and investment to solve for. And LoRa doesn't have that problem. Now, of course, what we want to do is make sure that the disadvantages of that singular IP ownership, which could come about, which would be one provider, one source of chip, doesn't hold LoRa back. And because of that, we followed quite an aggressive IP licensing policy to ensure that there are other suppliers who, again, can reach parts of the market that we can't reach, that understand customer needs that we don't understand, and have skills and capabilities that we don't, like ST Micro, for example, to use that common IP. Fundamentally, the radio layer is still the same, but to package it in different ways and take it into other areas of the market, which is exactly what ST is doing with their SoC that they released last year, which is a fantastic product. So that's kind of how LoRa sits within Semtech and how we think about LoRa within the broader ecosystem. It's a homogeneous layer. We want to ensure diversity of supply. We want to ensure diversity of ideation. And we have always fervently believed in, we are led by our ecosystem. We are driven by our ecosystem. They are our customers and our masters at the same time, because that's how you, I think, solve a global scale problem like how to connect all of these devices to the cloud.
Great. Okay. And maybe you can give us a quick briefing on where LoRa fits into the universe of connectivity solutions. So it seems like the value proposition is split a little bit between extremes. On the one hand, you're looking at open spaces, so wide open spaces, long distances. Even now, I understand satellite connectivity. On the other end of the extreme, you're looking at indoor spaces with a lot of walls or physical impediments. So maybe you can, what are the specifications that make LoRa a suitable solution for these two quite divergent environments?
Yeah, that's a good question. I mean, a lot of it comes down to range, because you'd expect me to say in connection with satellites. It's range, low power, and mobility. Now, in the smart home setting, and also in the enterprise and industrial space, one of the other characteristics of LoRa is that it's both an extraordinarily resilient signal, in that it propagates very well through really challenging environments. You mentioned walls and steel machinery and all the rest of it. That's something that we see, really driving adoption. It means that as an enterprise customer, for example, I don't have to go through a network planning exercise in my factory. I can install a gateway at one end of the factory and a gateway at the other end of the factory, and I can be confident that the entire factory is covered. It's the same reason why we see LoRaWAN used in solutions like panic buttons for hotel workers. If you're trying to give a tool, as is required by law now in many states in the US, a tool to workers to call for help when they need it, that tool better work wherever they are. It better work in the stairwell, it better work in the lift shaft, and that's exactly what LoRaWAN enables. Now, from a satellite perspective, there's a really three different models now of deploying LoRaWAN networks. The first is public LoRaWAN networks, and there's now an ever-growing range of network providers globally, and we're going down the age-old path of seeing those folks deepen and broaden coverage. There is private deployment, as I mentioned earlier, but now there is also satellites provide infill coverage for LoRaWAN-based devices, with the addition of it's a slightly different modulation. And I'm going to try and avoid going down the technical rat hole, but it's a slightly different modulation that lends itself to super dense deployments or really long range connectivity in the form of satellite, both low Earth orbit satellites and geostationary satellites, obviously, which are at much higher altitude above the Earth. But those networks are really about supporting things like logistics applications, tracking assets as they move around the planet, wildlife, agriculture, livestock, that type of thing, where you have remote and geographically distributed assets. You need to know where they are. And that's where we see the satellite scenario coming into play. And that's something where we've seen a lot of interest, a lot of activity in the course of the last year.
Okay, clear. So just to make sure that I'm understanding the architecture correctly, let's say we have a farm. The farm has maybe internet connectivity in the barn, in some central building. Would it be the case that you then place a LoRa gateway that would connect to that connectivity, whether that was, that could be a satellite or cellular? Or
that's a good question, Eric. I mean, I was going to say, so there's one model which is I have connectivity. I'm going to plug in a gateway at the end of that connectivity, and using that gateway connect, tags on my 10,000 herd of cattle to that single gateway, and I'm going to use the internet connection as backhaul to the cloud where I'm depositing the data. Backhaul can be plugged back. It can be a cable. It can be, we see a great deal of usage of cellular as a backhaul. So cellular capable gateways that sit on a truck, and inside the truck, the gateway is collecting data from tens or hundreds or thousands in some cases of assets, and using that single backhaul to pump the data up to the cloud. Satellite, fits into that slot as well. So really, any type of backhaul connectivity you can plug into the back of the gateway. You can use LoRaWAN in the local area, or indeed the quite wide area around you, to capture data from disparate sensors that run on coin cell batteries. And because of the power profile of LoRaWAN, those sensors, depending on how frequently they send data, of course, they can last up to 10 years on a single coin cell battery. If you were to use a cellular connection to each of those sensors, for example, there's the cost consideration of a cellular module, but there's also the power consideration, which in operational situations like agriculture, like beef farming, the operational cost of catching a cow and sticking a battery in a sensor pretty much washes away any benefit that you generated from the IoT solution in the first place. So that's the private deployment model really kind of falls into that kind of model of other backhaul, LoRa WAN, connecting all the sensors. There's also public network coverage. So as I mentioned, we've got, I think, 100 plus countries now where there's wide area coverage using LoRa WAN that supports a range of activities, particularly, say, let's take Western Europe, for example. We have fairly contiguous coverage throughout Western Europe, which means you can drive a truck using LoRa WAN as the backhaul through multiple countries and still collect the data from the assets sitting on that truck. But those really are the two. The satellite kind of is a little bit of a hybrid, really, to be honest, because it's public provision. But it's either a LoRa WAN backhaul or something else backhaul, and that something else can be pretty much anything that you want it to be.
Okay, interesting. So if I'm a farmer in Texas, I suppose this is a bit more of a CapEx solution. I have my private land and I'm putting in the infrastructure to reach the extent of maybe where my herd's grazing. If I'm, let's say, a bike as a service operator in Europe, then I might be using the public infrastructure. What would be the business model? Is that an OpEx? You pay per device, per month, per year? What would the business model look like there? The cost structure?
It varies. We see a variety of different approaches. There is available for many providers the one price. You pay a monthly charge. We see that quite a lot in areas like smart building, where building managers, they don't really want to get into the complexity of buy the device, connect the device. So they go to a provider. Microshare is a fine example, actually. Microshare is a member of the LoRaWAN ecosystem. They focus on smart building solutions, and they will provide you with a as a service offer. You pay per month per sensor. At the other end of the scale, of course, you can go out to any number of OEMs in the market and buy LoRaWAN sensors that you can then either connect to your own private network if you're going to deploy the gateway yourself, or you can provision onto any one of the public networks that's available. And in that model, you pay a connectivity charge per device. That flexibility, I think, is really key in IoT, because for a lot of customers, upfront CapEx is challenging. They want to pay as they go and pay as they accrue value. And so those as a service models, I think, are really important, not just in LoRaWAN, I think in IoT in general, actually.
Oh, gotcha. And then the network operators, are these typically more maybe niche or very focused providers, or are these companies like Telefonica and Deutsche Telekom that would then deploy this in parallel to their cellular networks?
Again, it's both. We have a number of folks, EveryNet, who are operating in South America, Southeast Asia, Triple Enco operating in Australia. They're small. They're LoRaWAN specialist operators. That's what they built their business around. They built public network infrastructure, and they're selling services around that public network infrastructure. We also have the Orange traditional telcos who are using LoRaWAN as it's an add-on. Because as I said earlier, cellular is a fabulous tool for a lot of IoT applications, particularly higher bandwidth. But if you've got to connect, 100,000 assets for bikes, for example, if you've got to connect 100,000 assets, and those assets have got to be able to survive on a very low power budget for a very long time, then cellular is not a great solution. Cellular-based technologies like NB-IoT don't have power profile of LoRaWAN. They're more power hungry. LoRaWAN's a great additional tool, and the way that certainly we see the world, and I'm happy to say more and more IoT solution providers are seeing the world is, as I said, application developers need a toolbox. That toolbox needs to have a range of things in it, including a solution to a low power, long range scenario. But it's as valuable as those individual technologies are. That value only increases if they're interoperable. From a developer's perspective, I don't want to care so much about what the connectivity layer is. I want to make decisions about the power I want to spend and the data I want to get. But that's really as far as it goes. I don't want to get into the specifics of the underlying network. And so interoperability between cellular technologies, Wi-Fi, and we work extensively with the World Wireless Broadband Alliance, that interoperability is really key. And that interoperability is reflected in the operator base that we see. We see traditional telcos, we see new guys, we see a whole range of different things.
Gotcha. Okay, very clear. And then you also have a set of platforms supporting, I suppose, device, maybe integration would be the right way to phrase it, and then also asset management. So you have the LoRa Edge platform. Are these separate platforms, or is LoRa Edge the platform that somebody would also be using to?
LoRa Edge is the best way to think about LoRa Edge is it's really the third generation of LoRa silicon. It does a couple of things that are really quite unique. And it was driven by, what we saw customers asking for in the asset management / logistics / that group of IoT use cases that spans multiple industries, where the knowledge of something, where something is and where it was, is a key input into the application. And that as I said, it spans pretty much every IoT use case. What LoRa Edge does is it brings the low power capability of LoRaWAN, but it also brings the ability to use GNSS, GPS based location and Wi-Fi based location from a single chip. So today, pre-LoRa Edge, if I wanted to build a device that could provide location data indoors and outdoors in a consistent way, I would have to build a device maybe with a cellular modem and a Wi-Fi chip added onto it for indoor location, or UWB, or one of the other indoor location technologies. And that device, the BOM cost, the physical cost of building that device, and the power required by that device, was often a barrier, really. What LoRa Edge does is it does away with those extra chips, and it does away with that extra power demand, and it enables customers to build a device that can provide location data regardless of where it is, whether it's indoors, outdoors, and thanks to both public and private LoRaWAN networks and satellite, pretty much wherever it goes, you can tell where it is. There's a trade-off in that GPS, full GPS, is extraordinarily power hungry, but it'll tell you with a fairly high degree of accuracy where something is. LoRa Edge operates a slightly wider range in terms of accuracy. The trade-off between power and that accuracy is one that in many industries where the ability to track something using a battery-powered sensor is key, that works very well and it fits that need perfectly. So we're seeing lots of uptake in asset tracking, logistics, etc., as you say. But when we say platform, at least at the silicon layer, it's a piece of silicon. Now, what LoRa Edge also does is it integrates into a cloud service which takes that GNSS data and takes that Wi-Fi data and turns it into what you want as a developer, which is, where is it? I don't want to know that you can see 10 satellites. I want to know where it is. And so when we talk about platform, we mean the endpoint and we mean the back-end cloud service that returns to the developer over an API call the location coordinates of that asset that they can then use in their application to go, do great things for their customers.
So I want to get into applications, but just one last line of questions on the technology side. If we can do kind of a rapid fire through the specifications. So you've already mentioned, and I know the answer here is always to some extent, it depends, but you mentioned for battery life, kind of maximum 10 years, depending on data transfer. Range is, what is the range? Is around 5 miles if it's clear, or what is the potential there?
I think I'm correct in saying, and Lynn, you may need to correct me after because it changes so rapidly. I think the longest ever recorded is 600 plus kilometers for terrestrial. But typically, ranges that we see in applications are anything from 500 yards to 5, 10, 15 miles. It does, unfortunately, as you say, the answer is it depends. If you're in an area that's built up with stone buildings, if you're in Frankfurt or London, or that range can be lower, 5, 10 miles range. If you're in the middle of the Sahara Desert, then you can expect to have a couple of 100 miles range with no problem at all. Power does depend. Again, it's something that we watch fairly closely, and we compare and contrast different use cases with other technologies. The basic rule of thumb is for a device that sends data 5 times a day, a reasonable expectation is to see 10 years life out of a coin cell battery. If you're sending data every 2 seconds, that obviously it flexes accordingly. But it's in that kind of range. We can give you some specific technical specs if that's helpful as well.
No, just to get a sense. And for accuracy, are we talking about maybe accuracy to within 10 meters, or what would be reasonable for location tracking?
Yeah, certainly within 10, down to as little as 5 meters, sometimes below. For outdoor GNSS based, obviously for Wi-Fi, it's tighter than that. It's no different from the level of accuracy you get from other Wi-Fi based tracking solutions. For GNSS, there is a slightly greater range or lower level of accuracy, as I said, because the calculation of that location is done in the cloud, and that's partly why the device is so low power. But there is some trade-off between that power saving and accuracy and the cost of the device itself, as I said, with GPS.
Gotcha. And then the cost, let's say we have a temperature humidity sensor that we want to put in, in a farm somewhere. What would be the cost of the BOM? Are we just for the transceiver?
It varies. I mean, it varies. The typical cost of sensors that you see, I mean, I kind of think, often the consideration about cost is what does the use case bear? So, for a temperature sensor, you shouldn't be looking at more than 10, 15, 20 euros, something of that order. That's kind of the sweet spot. But obviously in the market, our customers, it depends what you can buy very, very high-end sensors that have extraordinarily high levels of accuracy, and they tend to cost more, and you can buy sensors that are much more simple and they tend to cost less. It really is a mixed bag. It comes down really to what does the customer need to do, what problem are they trying to solve, which tool is the right one for the job. As we said earlier, one of the things we focused on is making sure that there is a rich and vibrant ecosystem of partners, and as members of the LoRa Alliance, doing our part to help support that growth, so that those solutions and those hardware choices do exist for customers.
Well, let's go into some of the applications. I imagine this is the type of solution that has hundreds of different applications, but what are the ones that you see being deployed most commonly today?
That's a good question. I mean, right now, utilities has always been a real sweet spot for LoRaWAN. In many ways, utilities is kind of where the technology started, and particularly for AMR, automated meter reading. And the reason for that is penetration. I can get below ground, below layers of concrete, and still support a very significant range. And utilities is one of those markets where it's a very simple cost calculation. I can employ someone to walk around and read each meter, or I can automate the collection of data. And so we see lots of companies globally using LoRaWAN for meter reading. We see heavy use in the smart building space as well. I mentioned Microshare earlier. Capgemini is another great example of a company that's used LoRaWAN to roll out building management solutions to their offices globally. We see lots of use in the asset tracking space, logistics space that I talked about. Where is it? What's happening to it? Is it lost? And that can range from finding tools on a work site to finding shared rental bikes to finding cows. We see a lot of use in smart home, both for LoRa and for LoRaWAN. And the distinction is we see lots of customers who are using LoRa as a radio layer and building their own customized protocols. The Amazon Sidewalk network is a good example of that. And we see, I'd say beyond that, there's a long tail in the IoT. I don't need to tell you, I'm sure. Agriculture is a fairly significant area of adoption. It's a relatively small market, I think, in IoT. The ability to deploy a private network on the farm is something that really makes LoRaWAN stand out. That I don't have to go to my local cellular operator and try and encourage them to improve coverage. And I don't, the cost profile and the management and the ownership profile lends itself there. But literally, and I say this all the time, every single day I find a different use case that I didn't know about before and go, oh, holy cow, that's, wow. I never thought that someone would have thought of doing that with LoRa. I guess that's the joy of working in this space and building tools that enable developers to go do interesting things. As I said, they'll do interesting things. They'll come up with all sorts of solutions to real world problems.
Absolutely. Is Semtech involved in maybe with key accounts? Are there customers where you work hand in hand with them, or is it typically you provide the silicon and the software, and then maybe they work with a system integrator or independently build the solutions?
I've got the stock answer. It depends. It really does depend. I mean, I think we're fortunate in that we have an extraordinarily skilled ecosystem. We spend a lot of time with ecosystem partners, helping them with radio design challenges and helping them, if they're newer entrants to LoRaWAN, maybe they're coming from a space where they've used other technologies, obviously helping them to onboard and to build their first products. With some customers, yes, we're directly involved with the end customer. But to be really clear, we don't sell solutions. Our ecosystem sells solutions. So where we do have involvement with end customers, it's in facilitation of our ecosystems, business, not ours. We sell silicon chips, and we do monetize some of our cloud services. We don't build solutions, we don't operate networks, and we don't. That's something that we've very, very deliberately left to a broader ecosystem to support the choice that customers need.
Gotcha. Makes sense. What's next for LoRa and LoRaWAN? So what are the areas where you see in the next 5 to 10 years there could be significant improvement in terms of what is it some particular specification or simplicity or new functionality?
Certainly simplicity is something that we're very, very focused on. And as I said, somewhat glibly earlier, developers want easy, and there are a number of things that we're working on which will kind of go further down that path. Of course, maintaining and improving on LoRa's range and power consumption, and that's something that we're constantly looking at. Improving geolocation accuracy is something that we're looking at. In the ecosystem itself, we're at a point now where we've got really quite a healthy roaming model, but that's obviously something that's really key. As I go from network to network, I can roam technically, but I want to be able to roam, commercially as well. And there are a couple of providers who've emerged, offering roaming hubs, and I think that's going to continue to grow as well. And then really, I think optimizing LoRaWAN for areas of the IoT market where, there are still gaps. And, I think the smart home market is one of those areas where the constant drive for lower cost and for lower power is one that will continue. So there's a range of different areas, but through a lot of what we do is, as I said earlier, as a member of the LoRa Alliance really does an excellent job in driving the evolution of the protocol based on the many, feedback from the many members engaged in the LoRa Alliance and from the many customers that they work with. And we're participants in that. But on the silicon layer, we're mostly focused on make it better, make it work more efficiently, increase the range, increase the accuracy, provide a simpler set of tools that does the job even more effectively for developers. Gotcha.
Great. Well, I think we've covered a fair bit of ground already today. Is there anything important that we missed?
We could talk forever. But no, I think that covers the basics. Hopefully that gives people a kind of a good high-level understanding of what LoRa does, what LoRaWAN does, what the difference between the two is and how it works. It's a complex space. I always think that the IoT ecosystem as a whole, I'd include myself in that. Simplicity has not been as much of a focus really, and you see that reflected in the tools that are available today. Particularly on the edge, particularly for connectivity. And we've talked quite a lot about our intent as part of our ecosystem to change that. And hopefully some of the folks listening who work in other ecosystems, they are working on the same types of initiative because, at the end of the day, developers need simple. They need a toolkit that they can pick and choose from according to the needs of the job. And that toolkit needs to comprise multiple connectivity methods that are all equally easy to use and equally easy to use together, not just independently.
Last question is, if somebody wants to learn more about how they might make use of LoRaWAN, what would be the best resource? Is this the LoRa Alliance? Is it Semtech? Is there a resource hub somewhere that people should be using as their first stop?
The LoRa Alliance is an excellent place to start, particularly in terms of understanding the many use cases that LoRaWAN supports today. We also offer a range of developer education and tools through our developer portal, which is LoRa/developers.semtech.com. And there is both higher level kind of educational material there, like what is it and how does it work, but also we're increasingly focusing on kind of guided learning labs that you can go through as a developer that kind of get you there quicker and make the process of building your first solution, your first Blinky, making that really simple so that developers kind of can get to the real business, can get to building applications. So those are two excellent resources. There are lots of folks in the ecosystem as well, providers who really do provide excellent education tools, companies like Actility, for example, Senate in the US. They provide a lot of material that will help people understand, what they can do with LoRa WAN and how it works.
Great. Well, Alistair, really enjoyed the conversation. Thanks for making time today.
Yeah, I enjoyed it as well, Eric. Thanks very much.
Thanks for tuning in to another edition of the Industrial IoT Spotlight. Don't forget to follow us on Twitter at IoT ONE HQ and to check out our database of case studies on IoT1.com. If you have unique insight or a project deployment story to share, we'd love to feature you on a future edition. Write us at eric.walenza@iot1.com.